This video summarizes the basic information that calculus tells us about the geometry of a function. When f of x and the derivative of f of x is positive, that means that f of x is increasing. When the derivative is negative, that means f of x is decreasing. And when the derivative is 0 or undefined, that means you have a critical point, which means it is a possible maximum or minimum. And you might use the first derivative test to determine whether it's a max or a min. The second derivative tells us about concavity. If the second derivative is positive, it's concave up. Second derivative is negative, it's concave down. Where the second derivative is 0, then we have a potential point of inflection. That is to say, a point where concavity changes. And we might also evaluate whether the critical points are max or min by using the second derivative test. So let's demonstrate this by looking at a particular function, f of x equals x minus 3 to the power of 1/3. Well, first of all, some pre-calculus stuff we can do. If we plug in 0, what we get is negative 3 to the 1/3, so that is the negative cube root of 3. That is the y-intercept. If we solve the equation f of x equals 0, that gives us a solution of x equals 3. So x equals 3 is the x-intercept. That is the only root of the function, the only intercept. So those are two examples of just pre-calculus techniques. Now we're ready for some calculus. We'll take a derivative. Derivative of this function is 1/3 x minus 3 to the 1/3 minus 1. That would be negative 2/3. So interestingly, what happens with this function? Well, first of all, notice that this function doesn't equal 0 anywhere. Here, if we plug in f prime of 3, what we get is 0 in the denominator. We get undefined. And so this is a critical point because the slope is undefined there. That's interesting. Also notice we can rewrite this slightly as 1/3 1 over x minus 3 to the 2/3. Well, 2/3 is an even power, which means that if we put in a positive, we'll get a positive. If we put in a negative, we'll get a positive. And so this derivative, except where it's undefined, is always positive. So what we have is, we have this critical point at 3, and it's positive before that and positive after that. So it appears that this is a function that is always increasing. So right away that suggests that at 3, whatever is going on at 3, it's neither a maximum nor a minimum. Well, now we'll take a second derivative, and this will be 2/9 x minus 3 to the negative 5/3. And we can rewrite this as 2/9 and then 1 over x minus 3 to the 5/3. And of course, this is also undefined when x equals 3. But what we notice is that when we plug in values of less than 3, we get a negative. 5/3 of a negative number to the power of 5/3 is negative, times the negative 2/9 gives us a positive. When we plug in a positive number, a number bigger than 3, well then 5/3 of that, 5/3 power will also be positive, multiplied by negative 2/9, that will be negative. So the function is concave up before it gets to 3, and it is concave down after. And so what that means is that 3 is a point of inflection of the function. And in fact, what the function looks like is something sort of like this. It is concave up and increasing before it gets to 3. At 3, temporarily, it gets an infinite slope just for a moment there. That's why the slope is undefined. And then after that, it continues increasing concave down. And this is the shape of the function.